Good morning everyone. Before moving towards Poisson distribution, let me in brief list down what is the function of binomial distribution and the various properties of binomial distribution. ठीक है, so let's begin. सबसे पहली चीज बाइनोमियल डिस्ट्रीब्यूशन जो है वो क्या है? डिस्क्रीट डिस्ट्रीब्यूशन है. बाइनोमियल डिस्ट्रीब्यूशन जो है वो बाय पैरामेट्रिक डिस्ट्रीब्यूशन है. इट इज बाय पैरामेट्रिक डिस्ट्रीब्यूशन. जो दो पैरामीटर्स हैं दैट इज n, p, where n is your number of trials, correct, and p is your probability of success. P is your probability of success. ठीक है, अभी P अगर probability of success है तो Q को हम कहते हैं probability of failure. करेक्ट, P plus Q is equal to 1. ठीक है, P plus Q is equal to 1. The function of the binomial distribution is given as f of x is equal to ncx p raised to x q raised to n minus x. डिस्क्रीट वैल्यूज के लिए है, इट स्टार्ट्स फ्रॉम 0, 1, 2 एंड सो ऑन अप टिल 3. और क्योंकि डिस्क्रीट की बात चालू है तो टोटल जो है वो 1 रहेगा और इंडिविजुअल वैल्यूज greater than equal to 0. Then we studied about the properties. Mean of the binomial distribution is n into p. Variance of the binomial distribution is n into p into q. And you need to remember that mean is always greater than variance. फिर हमने एडिटिव प्रॉपर्टी जो है वो सीखी. एडिटिव प्रॉपर्टी ऑफ बाइनोमियल डिस्ट्रीब्यूशन. अगर हमारे पास दो डिस्ट्रीब्यूशन है, से x विच इज से n1, p, करेक्ट, एंड से दूसरा डिस्ट्रीब्यूशन है से y दैट इज से n2, p, तो इन दोनों का कंबाइंड एडिटिव प्रॉपर्टी कहता है your binomial distribution will be n1 plus n2, p. फिर हमने कुछ और इंटरेस्टिंग प्रॉपर्टीज भी देखे, करेक्ट. So the property, it's about mode of the binomial distribution. So सबसे पहले आपको क्या करना है, आपको n plus 1 into p, ये है हमारे मोड का फॉर्मूला जो कि डिनोट किया गया है म्यू 0 से. अब इसका जो भी आंसर आएगा अगर पॉइंट में आता है तो इसका मतलब वो क्या है, नॉन इंटीजर है. इट इज नॉन इंटीजर. तो उस वक्त हम क्या करेंगे, जो भी हमें वैल्यू आई है से 9.5, 9.7, 9.8, 8.8, तो इसमें इंटीजर पार्ट क्या है जो कि पॉइंट के पहले है, जैसे 8 हो गया, 9 हो गया. सो वी consider the largest integer in this. We consider the largest integer. लेकिन अगर मुझे ये n plus 1 into p कोई इंटीजर आ गया, जैसे 5, 6, 10, -5 एंड सो ऑन, अगर कोई मुझे इंटीजर आ गया तो फिर मैं क्या करूँगा, इट विल बी n plus 1 into p and n plus 1 minus p. दिस आर गोइंग टू बी मोड. अभी जब आपको किसी डिस्ट्रीब्यूशन के दो मोड मिलते हैं हम उसे कहते हैं बाय मॉडल, और यहाँ पर आपने एक ही निकाला तो हम उसे कहते हैं यूनी मॉडल, करेक्ट. वंस दिस प्रॉपर्टी इज डन, द लास्ट प्रॉपर्टी इज व्हेन योर बाइनोमियल एंड Poisson your binomial distribution gets the maximum value of variance. Correct. So that is at the value n by 4, वैल्यू n/4 और हमारा p और q जो है that should be 0.5. Correct. When p is equal to q is equal to 0.5, the maximum value of the variance in binomial distribution is n/4. Correct. So it is n/16. N plus 1 into p, then n plus 1 into -1. Okay. So now we can move towards the Poisson distribution. अभी जैसे हम कहते हैं बाइनोमियल डिस्ट्रीब्यूशन कब अप्लाई करना चाहिए, व्हेन यू आर एबल टू कन्वर्ट एनी गिवन एक्सपेरिमेंट इनटू ओनली टू पॉसिबल आउटकम्स, राइट, ओनली टू आउटकम्स, ओनली टू आउटकम्स। जब आप गिवन एक्सपेरिमेंट को सिर्फ और सिर्फ दो पॉसिबल आउटकम्स में कन्वर्ट कर सकते हैं तो आपको बाइनोमियल डिस्ट्रीब्यूशन अप्लाई करना चाहिए। Similarly, when we should apply Poisson distribution, correct? Applicable, like when Poisson distribution is applicable, when your probability of success is almost moving towards zero, जब probability of success जीरो की तरफ मूव कर रहा है और n जो है वो आपका बहुत 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 बड़ा है, इट्स वेरी वेरी लार्ज, n is moving towards infinity. Correct. So I can say that when Poisson distribution is applicable, when the probability of success, when the probability of success is very low, when the probability of success is very low and the sample size is very very large, the sample size is very large, sample size is very large, at this point of time you are going to use your Poisson distribution. So as जैसे हमारे पास बाइनोमियल डिस्ट्रीब्यूशन में फंक्शन है, ठीक वैसे ही हम आगे बढ़ेंगे। बाइनोमियल डिस्ट्रीब्यूशन जो है वो डिस्क्रीट डिस्ट्रीब्यूशन था, आवर Poisson डिस्ट्रीब्यूशन इज ऑल्सो डिस्क्रीट। Poisson distribution जो है, even this is a discrete distribution. फिर binomial distribution was biparametric, this is a uniparametric distribution, uniparametric distribution. The parameter used is m, m को हम कहते हैं mean number of success या mean success, the way you want you can remember it. I remember it as mean success, या आप इसे एवरेज सक्सेस भी कह सकते हैं, एवरेज सक्सेस। देन नेक्स्ट पॉइंट, से द फंक्शन of the binomial distribution was ncx p raised to x q raised to n minus x. So here the probability distribution function for Poisson is given as, say, f of x is equal to e to the power minus m, m raised to x upon x factorial. Again, since it is a discrete distribution, so x will be 0, 1, 2, 3 and so on up till n. यहाँ पर m तो है, वो है हमारा मीन सक्सेस, x हमारा वेरिएबल है, x is our variable. So E in our distribution is nothing but your universal constant. E is your universal constant and it is given by, the value of the E is given as 2.718289, लेकिन हमें 8284590 समथिंग कुछ है, बट डेसिमल के बाद 3 प्लेसेस तक हमें याद रखना है. So that is the value of E. Correct. Next, क्या था, मीन एंड वेरियंस. यस, इन दिस आई कैन से योर मीन इज इक्वल टू वेरियंस. Your mean is equal to variance. Correct. Since mean is equal to variance, so the formula for both turns out to be n into p. N into p. Now, when we say that m is equal to n into p, now my p is very small. My p is very small, and my n is infinite. It's moving towards infinity. It's moving towards infinity. Then the product of the both, correct? Then the product of the both will be very small. Do you all agree with this? Then the product of both will be very small. Correct? बहुत छोटा आएगा. करेक्ट. तो ये चीज हमें ध्यान रखनी है, बिकॉज नो समटाइम्स दे आस्क यू लाइक इफ what your p is moving towards 0 and your n is moving towards infinity, then your mean, which is equal to n into p, what will be the value? So the value is going to be very small. But yes, I can also say that no doubt value is very small, but it is going to be what? Finite. Correct. We are multiplying with a very small value, that is infinity, right? A very huge value. So जो product आएगा वो क्या आएगा? एक finite ही आएगा, लेकिन वो भी बहुत छोटा होगा. So the sorry, mode of the Poisson distribution, again it can be unimodal or bimodal. तो पहले हम मोड फाइंड करेंगे. मोड कैसे फाइंड करेंगे? बाय द वैल्यू ऑफ m. अगर m जो है वो आपका नॉन इंटीजर आ जाता है, इफ m इज नॉन इंटीजर, करेक्ट, तो इसमें आप लार्जेस्ट इंटीजर ढूंढेंगे. व्हाट इज द लार्जेस्ट इंटीजर इन दिस वैल्यू? और अगर ये इंटीजर आ गया, इफ माय m टर्न्स आउट टू बी इंटीजर, then this is going to be m and m minus 1. So it is going to be again bimodal. It is going to be bimodal. As we have the additive property in binomial distribution, similarly we have an additive property over here, and the additive property is similar. अभी वहां पर तो बाय पैरामेट्रिक था, ये तो यूनी पैरामेट्रिक है. ठीक है. तो अगर x जो है, x is a uniparametric distribution, say m1, x is one of the distribution in m1. Similarly, y is another distribution, say m2. तो x plus y क्या हो जाएगा? It is going to be m1 plus m2, क्योंकि बात तो यहाँ पर probability की है ही नहीं. तो sometimes they also ask you कि x और y कैसे variables हैं. So we know very well, correct, we have studied this earlier, these are independent variables. करेक्ट. x एंड y आर इंडिपेंडेंट. तो अगर x और y इंडिपेंडेंट है, क्या मैं कह सकता हूँ x प्लस y विल ऑल्सो बी एन इंडिपेंडेंट वेरिएबल? इफ x एंड y आर इंडिपेंडेंट, कैन आई से दैट मीन्स इवन x प्लस y विल बी इंडिपेंडेंट? ये तो वही बात हो गई. अगर मैं आपको कहता हूँ x इज अ कांस्टेंट वैल्यू, y इज अ कांस्टेंट वैल्यू, then the addition of two constants value will be what? Constant. Correct. Everybody understood this point? So this were few I can say examples where your binomial distribution, sorry, Poisson distribution is applied. Let us go ahead for the very first example of Poisson distribution. Let's begin. So what it's given is between 2 p.m. and 2 and 4 p.m. the average number of phone calls, correct? The average number of phone calls per minute coming into the switchboard of a company is 2.5. उन्होंने आपको एवरेज नंबर ऑफ फोन कॉल्स दिया है, मतलब उन्होंने आपको मीन दिया हुआ है. करेक्ट बोला है. देन द प्रोबेबिलिटी दैट ड्यूरिंग वन पर्टिकुलर मिनट देयर विल बी, करेक्ट. So whenever they give you such questions, they surely give you the value of e. So it is e raised to minus 2. वैल्यू दी गई है आपको 0.1354 and e to the power minus 0.5. They have given the value as 0.60650. करेक्ट. सो दीज आर द वैल्यूज विच दे हैव गिवन. बोला है पहली बिट दैट देयर इज नो फोन कॉल एट ऑल. अभी क्वेश्चन से ही मुझे उन्होंने मीन तो दे ही दिया है. करेक्ट. एवरेज नंबर ऑफ फोन कॉल्स अ मिनट दैट दे हैव क्लियरली गिवन टू मी. और पॉइसन डिस्ट्रीब्यूशन यूनिपैरामेट्रिक है. अगर मुझे m मिल गया मतलब मुझे और किसी चीज की जरूरत ही नहीं है. सो m इज व्हाट 2.5. अब उन्होंने बोला है that there is no phone call. First bit, that is there is no phone call. मतलब हमारा x का वैल्यू क्या हो जाएगा? What will be our value of x? There is no phone call means there is p of x equal to 0, जिसको मैं लिख सकता हूँ p of 0. Now what is our function for Poisson distribution? It is e raised to minus m raised to x upon x factorial. Correct. So e raised to minus m means e raised to minus 2.5. m is 2.5, so it is going to be 2.5 to the power 0 divided by 0 factorial. So you are going to get this as e raised to minus 2.5. अब प्रॉब्लम ये है कि उन्होंने आपको वैल्यूज दिए नहीं है, बट वी नो बाय लॉज ऑफ इंडाइजेस, by laws of indices, can I say it is going to be e raised to minus 2 into e raised to minus 0.5. Everyone, do you all agree with this, that by laws of indices can I write e raised to minus 2.5 as e raised to minus 2 into e raised to minus 0.5. Now they have given you both the values. So probability when there is no phone calls, it is going to be 0.1354 into 0.60650. Correct. So that turns out to be 0.0821. Correct. So that is the answer for 0 phone calls. So second bit जो दिया गया है वो है probability that there are at least 7 phone calls. So at least 7 phone calls means p of x greater than equal to 7. So greater than equal to 7, n तो है नहीं हमारे पास, तो हम 7 से शुरू तो कर लेंगे. We'll start with 7, then 8, then 9. ये तो आगे बढ़ते ही जाएगा. Where to stop we don't know, but yes, I can surely say it is 1 minus probability of x less than 7. So this will be 1 minus in bracket p of 0 plus p of 1 plus p of 2 plus p of 3 plus p of 4, p of 5 and p of 6. Now you already know the value of m. So this is going to be 1 minus e to the power minus 2.5. Correct. 2.5 to the power 0 upon 0 factorial. E to the power minus 2.5. 2.5 to the power 1 upon 1 factorial plus e to the power minus 2.5, 2.5 square upon 2 factorial. Similarly, e to the power minus 2.5, 2.5 cube upon 3 factorial plus e raised to minus 2.5, 2.5 raised to 4 upon 4 factorial. Then e raised to minus 2.5, 2.5 raised to 5 upon 5 factorial. Then finally e raised to minus 2.5, 2.5 raised to 6 upon 6 factorial. अभी इन सभी में से आप e raised to minus 2.5 जो है वो कॉमन ज़रूर ले सकते हैं. करेक्ट. वी कैन श्योरली टेक e raised to 2.5 as common from all of these. So probability of x at least 7 is 1 minus e raised to minus 2.5 as common. First term it is going to be 1, second term is 2.5, correct. Third term 2.5 square by 2 factorial is 2. Next is 2.5 cube, 3 factorial is 6. 2.5 raised to 4, 4 factorial is 24. 2.5 raised to 5, 5 factorial is 120. And lastly 2.5 to the power 6, 6 factorial is 720. Correct. So this is how you are going to solve this question. So the calculations part, first you will solve the entire bracket, then you will multiply it by e raised to minus 2.5, and then you go for the subtraction. So this you are going to try yourself. Okay. So let us move ahead for the next question, and here it is, the another question. So now in this example, they are told in a factory turning out blades, correct. There is a 0.2% probability for any blade to be defective. Okay, so they have given us the probability of a defective blade. So blades are being supplied in the packet of 10. Okay, okay. Using Poisson distribution, calculate the approximate number of packets containing पहला bit no defective, then one defective, two defective, three defective blades respectively. और फिर बोला है in the consignment of 20,000 packets what you are going to get it. So you are being given that e to the power minus 0.02, it is given to you as 0.9802. The value is given as 0.9802. This is the value given to you. अभी इसमें उन्होंने आपको m का वैल्यू नहीं दिया है. They have not given you the value of mean number of success, but indirectly उन्होंने आपको n और p का वैल्यू दे दिया है. देखो कैसे, p हमें दिया है 0.2%, correct. मतलब probability that it is going to be defective will be 0.2 by 100, correct, and that is going to be 0.002. और हमें पैकेट कितने के बोले हैं, 10-10 के. तो ब्लेड्स जो है वो 10-10 के पैकेट्स में बनेंगे, तो हमारा n जो है वो 10 रहेगा. तो m क्या होता है, m is n into p, so that is 10 into 0.002, so that will turn out to be 0.02. उसके बाद हमें ये सब चीजें निकालनी है. फिर पूछा है कि अगर 10 पैकेट के लिए ये सब पॉसिबिलिटीज हैं तो 20,000 पैकेट्स में कितने डिफेक्टिव होंगे. ठीक है. सो लेट अस फर्स्ट कंप्लीट द इनिशियल बिट. पहला बिट क्या बोला है हमें, देयर इज नो डिफेक्टिव, करेक्ट. देयर इज नो डिफेक्टिव. नो डिफेक्टिव का मतलब क्या आएगा, probability they say that there is no defective. So what will be the value of x over here, 0. तो मैं डायरेक्टली लिखता हूँ, it is going to be p of 0, correct. It is e raised to minus m, that is e raised to minus 0.02, then m to the power 0 upon 0 factorial. So p of 0 तो डायरेक्टली मिल गया हमें, it is already given, it is going to be 0.9802. So no defective. Then उसके बाद क्या बोला है, one defective. So probability that there is one defective blade. So one defective blade will be p of 1, e to the power minus 0.02, 0.02 to the power 1 divided by 1 factorial. So this is going to turn out to be 0.9802 into 0.02. So what it's going to be is 0. How much? 0.0196 or 0.00196. Everyone, okay. 0.0196. ये हो गया for one defective. This is for one defective. Now, what if we have two defectives? So this is going to be P of 2. That is again going to be e raised to minus m to the power x divided by 2 factorial. That is 0.9802 into 0.2 square. It is going to be 0.0004 divided by 2 factorial is 2. Correct? 2 factorial is nothing but 2. So this turns out to be 0.000196. Okay. One more probability that there are 3 defectives. So e raised to minus 0.02, 0.02 to the power 3 divided by 3 factorial. So it is going to be 0.9802 into 0.2 cube. Correct. So it's going to be something. So give me the final answer for 3 defectives. Okay, it is 0.00001306. Correct. So these are the possibilities when we are talking about the packet as 10. तो हम लोग के पहले बिट्स हो चुके हैं. अब बोला है अगर कंसाइनमेंट 20,000 का था तो फिर कितने पैकेट्स डिफेक्टिव होंगे. तो सिंपल सी बात है, अगर 10 पैकेट्स के लिए आपकी ये प्रोबेबिलिटी है तो 20,000 पैकेट्स के लिए फॉर 20,000 पैकेट्स आप क्या करेंगे, 20,000 को मल्टीप्लाई कर देंगे. डू यू ऑल एग्री विद दिस? यस और नो? For 20,000 packets, you are going to multiply this by 20,000. Correct? Tell me what is the answer which is about to come. Similarly, इसको भी क्या करेंगे, multiply by 20,000. इधर भी क्या करेंगे, 20,000 मल्टीप्लाई कर देंगे into 20,000. इधर भी करेंगे into 20,000. Correct? So first it turns out to be 19604. That is in the consignment there are going to be 0 defective as 19604. The chances for 1 defective will be what? Okay, the chances for 1 defective, it's going to be 392. Chances for 2 defective, it is 3.92. chances for 2 defectives. So approximately I can take 4 packets. Yes or no? अभी मैं ऐसे तो नहीं बोल सकता ना 3 पैकेट और 92. So approximately I am considering it as 4 packets because the packets are in the form of 10. And then finally pre of 3, it will be something 0.026 something. So I am considering it as 0 packets. I can consider it as 0 packets. So that is going to be your final answers. So this is 0 packets 421960. So let's move ahead for the next sum, the next example. So in a certain elementary radiant packets from a source are emitted at an average rate of 2 per second. Okay, so it's a radioactive element emitting at the average rate of 2 per second. 1 सेकेंड में 2. Assuming Poisson distribution law, find the probability that there will be exactly 4 particles. There will be exactly 4 particles in 2 seconds. करेक्ट. ये तो बहुत ही सिंपल है. क्या मैं कह सकता हूं अगर 1 सेकेंड में 2, करेक्ट, तो कितने पार्टिकल होंगे 2 सेकेंड में? 4. यस और नो? उन्होंने हमें m का वैल्यू ही दिया है. करेक्ट. हाउ दे हैव गिवन द वैल्यू ऑफ m? क्वाइट लॉजिकल. करेक्ट. पहले कितने पार्टिकल हो रहे थे? करेक्ट. एट अ रेट ऑफ 2 पर सेकेंड, मतलब it is 2 particles per second. Yes or no? 2 particles per second. So what we need to find is 4 particles emitted in 2 seconds. Okay, so we need to find 4 particles, correct, emitted per 2 seconds. That is what we need to find. Correct. So it's quite easy. We need to find the probability for 4 particles. So P of x is equal to 4 means P of 4 e raised to minus m e raised to minus 4 m to the power 4 divided by 4 factorial. Now, so on calculations we got to know that the value of e to the power is 0.01831 and 4 to the power 4, that is going to be 256, and 4 factorial is 24. That turns out to be 0.1953. So that's the example completed. So let's move ahead with the next example. दिया गया है आपको if p of x equal to 2 is 9 times p of x equal to 4 plus 90 times p of x equal to 6. They have told find the value of the standard deviation. Correct. So it's simple to go ahead. Mean is equal to variance. करेक्ट. सो बात ही खत्म हो गई. स्टैंडर्ड डेविएशन भी आसानी से मिल जाएगा. हमें दिया है p ऑफ x इक्वल टू 2. करेक्ट. तो x इक्वल टू 2 मतलब e टू द पावर माइनस m स्क्वायर अपॉन 2 फैक्टोरियल इज इक्वल टू 9 टाइम्स, करेक्ट, x इक्वल टू 4 मतलब e टू द पावर माइनस m टू द पावर 4 अपॉन 4 फैक्टोरियल्स प्लस 90, करेक्ट, दिया है x टू द पावर 6 मतलब e टू द पावर माइनस m टू द पावर 6 अपॉन 6 फैक्टोरियल. करेक्ट. क्या मैं e रेज टू माइनस m कॉमन निकाल के कैंसिल कर सकता हूं क्या? देखिए ध्यान से, ठीक है. लेफ्ट हैंड साइड पे e रेज टू माइनस m स्क्वायर अपॉन 2 फैक्टोरियल है. मैं ये कह रहा हूं पहली बिट, फर्स्ट बिट, कैन आई टेक e रेज टू माइनस m कॉमन? फर्स्ट बिट, कैन आई टेक e टू द पावर माइनस m कॉमन? करेक्ट. देन I have over here m to the power 4, m to the power 6. I can also take m square common. So what is going to remain with me is 9m square by 4 factorial plus 90m to the power 4 by 6 factorial. Now I can easily cancel these two terms. E raised to minus m gets cancelled, m square gets cancelled. So now I am left with 2 factorial, 1 upon 2 factorial is 2, which is equal to 9m square, and then 4 factorial is 24 plus 90m to the power 4, 6 factorial is 720. Correct. So I can surely solve ahead. So how? So here 0, 0 will get cancelled. I can take 9 common and I can take 3 common, or I can also reduce these things over here. Correct. So it will be 3 3s are 9. 3 how much? 24. 3 8s are 24. Then again 3 3s are 9. Then 3 2s are 6. 3 4s are 12. Everyone agrees? Anybody having any doubts? So this will be 3 1s are 3, 3 8s are 24. So now what I have is 1 by 2 is equal to 3m square by 8 plus m to the power 4 by 8. So the base is same. Correct. So I can write this as, it is nothing but 1 by 2 equal to, this will be 3m square plus m to the power 4 by 8. I can again reduce it. 2 ones are, then 2 fours are. So I'm going to get this as 3m square plus m to the power 4 is equal to 4. So I'm getting this as m to the power 4 plus 3m square minus 4 equal to 0. So I will say let m square be equal to x. So I will get this as x square plus 3x minus 4 equal to 0. So what are going to be the factors? It's going to be plus 4 and minus 1. So x square plus 4x minus x minus 4 equal to 0. So x common, x plus 4 minus 1 common, x plus 4 equal to 0. So I will get x minus 1 and x plus 4 equal to 0. Now from here I got this as either x is going to be 1 or x is going to be minus 4. But what is our x? Our x is nothing but what? M square. So m square equal to 1 or m square equal to minus 4. Now this is never possible. Correct. M square equal to 1 means we will take m is equal to 1. So it can never take negative value. Now m is 1. Always remember m is going to be greater than 0. अगर m greater than 0 है तो e raised to minus m भी क्या होगा? ग्रेटर देन 0 ही होगा. करेंगे नेगेटिव साइन जो है ये क्या डिनोट करती है? दैट the values are small, but that doesn't mean, see इसका मीनिंग क्या हो गया? 1 upon e raised to m greater than 0. So the values are small, that doesn't mean that the value are negative. So always remember m is 1 या m is always going to be greater than 0. लेकिन क्या हमें उन्होंने मीन पूछा था क्या? Did they ask us mean? No. हमें m मिला है 1 यानी कि मीन मिला है, और मीन इक्वल है वेरिएंस के. हमें पूछा है उन्होंने स्टैंडर्ड डेविएशन. सो व्हाट विल बी द स्टैंडर्ड डेविएशन? स्क्वायर रूट ऑफ 1. yes or no? Standard deviation will be square root of 1, that is again turning out to be 1. Let's move ahead with the next question. P of x1 is equal to x2, then they have told find the value of mean. Again quite an easy sum to go ahead. So this is going to be e to the power minus m upon 1 factorial e to the power minus m square upon 2 factorial. So e raised to power minus m will get cancelled. One of the m will get cancelled. So we will directly get the answer for m as 2. Everybody agrees? We'll get the value as 1 is equal to m by 2 factorial that is you get the value of m as 2. Correct. Let's go ahead for the next one. It's quite easy. बोला है in binomial distribution n is equal to 20. In binomial distribution n is equal to 20. Find the mean if the distribution is symmetric. So we know that if the distribution is symmetric, correct, in theory we have studied at that point of time P is equal to Q. P is equal to Q is equal to 0.5. ठीक है, तो हमें बोला है मीन. व्हाट इज मीन ऑफ बाइनोमियल डिस्ट्रीब्यूशन? It is n into p, that is 20 into 0.5, that is going to be how much? Simple, it is going to be 10. So we'll stop here. In the coming lecture we'll go ahead for few more practice questions. Until that, stay home, stay safe, have a great day ahead. Thank you.